Okay, here we have two cylindrical swimming pools, and they're being filled simultaneously with water at the same rate, 10 cubic meters per minute. And whoever is filling these pools, they were both empty to start with, and they start pumping in the water at the same time to both pools. So that tells us that the volume of water in each pool is going to be the same, because both started empty, water is being pumped in at the same rate, and the pumping started at the same time for both pools. So let V1 be the volume of water in here, and V2 is the volume of water in pool 2. And we know that V1 equals V2. We can derive that from these first couple of sentences. Now the smaller pool has a radius of 5 and the larger one a radius of 8. And the height of the water in the smaller one at any given time is h1. And in the larger one it's h2. And of course the h1 and the h2 vary as time varies. And the question is, when the height of the water in the smaller pool is 1 meter, suppose that is 1, then what is h2? So the question is, when h1 equals 1, what is the value of h2? Well, this equation V1 equals V2 should give us some more information. We can actually say what V1 is in terms of H1. V1 is the area of the base of the pool here, which is just a disk of radius 5, and so that's pi 5 squared, which is 25, and then the volume of water is that times the height of the water, which is h1. And the volume of water in the second pool is pi by r squared, which is 8 squared, times the height of the water in the second pool. So that's 64 pi by h2. And because V1 equals V2, we have pi by 25 by h1 is equal to 64 pi by h2. So when h1 equals 1, we have 25 pi is equal to 64 pi by h2. We have h2 is equal to 25 over 64. Oops, sorry about that. It's 25 over 64, which is approximately 0.39, and now our units here are given in meters. So it's approximately 0.39 meters.